Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Dress4Win would like to become familiar with deploying applications to the cloud by successfully deploying some applications quickly, as is. They have asked for your recommendation. What should you advise? The options are: Option A, identify self-contained applications with external dependencies as a first move to the cloud. Option B, identify enterprise applications with internal dependencies and recommend these as a first move to the cloud. Option C, suggest moving their in-house databases to the cloud and continue serving requests to on-premise applications. Option D, recommend moving their message queuing servers to the cloud and continue handling requests to on-premise applications.
To arrive at the correct answer, we focus on the keywords: familiar with deploying applications to the cloud, deploying some applications quickly, as is.
The correct answer is Option A, identify self-contained applications with external dependencies as a first move to the cloud.
Why is this correct? A. Starting with self-contained applications allows the team to gain cloud deployment experience quickly and safely without suffering from complex cross-environment dependencies or latency issues. Why are the others incorrect? B. Enterprise applications with heavy internal dependencies add significant complexity and risk, making them poor candidates for a quick initial migration. C. Moving databases to the cloud while leaving dependent application servers on premises introduces high network latency and performance degradation. D. Migrating message queuing components to the cloud while leaving dependent application components on premises increases latency and architecture complexity unnecessarily for an initial deployment.
Dress4Win has asked you for advice on how to migrate their on-premises MySQL deployment to the cloud. They want to minimize downtime and performance impact to their on-premises solution during the migration. Which approach should you recommend? The options are: Option A, create a dump of the on-premises MySQL master server, and then shut it down, upload it to the cloud environment, and load into a new MySQL cluster. Option B, set up a MySQL replica server/slave in the cloud environment, and configure it for asynchronous replication from the MySQL master server on-premises until cutover. Option C, create a new MySQL cluster in the cloud, configure applications to begin writing to both on-premises and cloud MySQL masters, and destroy the original cluster at cutover. Option D, create a dump of the MySQL replica server into the cloud environment, load it into Google Cloud Data Store, and configure applications to read/write to Cloud Data Store at cutover.
To arrive at the correct answer, we focus on the keywords: migrate their on-premises MySQL deployment to the cloud, minimize downtime and performance impact.
The correct answer is Option B, set up a MySQL replica server/slave in the cloud environment, and configure it for asynchronous replication from the MySQL master server on-premises until cutover.
Why is this correct? B. Setting up a replica in the cloud using asynchronous replication keeps data synchronized continuously without requiring production server downtime, enabling a seamless cutover with minimal downtime and impact. Why are the others incorrect? A. Shutting down the master server to dump, upload, and restore data causes significant extended downtime for the on-premises system. C. Dual writing from applications requires complex code changes and risks data inconsistency, split-brain issues, and performance overhead. D. Moving relational MySQL data to Cloud Data Store, a NoSQL database, requires extensive schema redesign and application rewrites, which is inefficient for a simple database migration.
Dress4Win has configured a new uptime check with Google Stackdriver for several of their legacy services. The Stackdriver dashboard is not reporting the services as healthy. What should they do? The options are: Option A, Install the Stackdriver agent on all of the legacy web servers. Option B. In the Cloud Platform console, download the list of the Uptime server's IP addresses and create an inbound firewall rule. Option C. Configure their load balancer to pass through the user agent HTTP header when the value matches Google Stackdriver monitoring uptime checks, https://cloud.google.com/monitoring. Option D. Configure their legacy web servers to allow requests that contain user agent HTTP header when the value matches Google Stackdriver monitoring uptime checks, https://cloud.google.com/monitoring.
To arrive at the correct answer, we focus on the keywords, uptime check with Google Stackdriver, legacy services, not reporting the services as healthy.
The correct answer is option B. In the Cloud Platform console, download the list of the Uptime server's IP addresses and create an inbound firewall rule.
Why is this correct? B. Stackdriver Uptime checks probe services using public IP addresses from external locations. If legacy services show as unhealthy, an inbound firewall rule must be configured to allow traffic from these probe IP addresses. Why are the others incorrect? A. The Stackdriver agent collects internal system metrics and logs, which is distinct from external uptime check probing. C. User agent header handling at the load balancer level does not resolve network level blocking caused by missing inbound firewall rules. D. Web server user agent filtering occurs after network connection establishment and cannot resolve blocked network traffic from uptime check IPs.
As part of their new application experience, Dress4WM allows customers to upload images of themselves. The customer has exclusive control over who may view these images. Customers should be able to upload images with minimal latency and also be shown their images quickly on the main application page when they log in. Which configuration should Dress4WM use? The options are: Option A. Store image files in a Google Cloud Storage bucket. Use Google Cloud Data Store to maintain metadata that maps each customer's ID and their image files. Option B. Store image files in a Google Cloud Storage bucket. Add custom metadata to the uploaded images in cloud storage that contains the customer's unique ID. Option C. Use a distributed file system to store customers' images. As storage needs increase, add more persistent disks and/or nodes. Assign each customer a unique ID, which sets each file's owner attribute, ensuring privacy of images. Option D. Use a distributed file system to store customers' images. As storage needs increase, add more persistent disks and/or nodes. Use a Google Cloud SQL database to maintain metadata that maps each customer's ID to their image files.
To arrive at the correct answer, we focus on the keywords, upload images of themselves, exclusive control, upload images with minimal latency, shown their images quickly.
The correct answer is option A. Store image files in a Google Cloud Storage bucket. Use Google Cloud Data Store to maintain metadata that maps each customer's ID and their image files.
Why is this correct? A. Cloud storage provides scalable, low-latency object storage for image files, while Cloud Data Store offers fast NoSQL querying to map customer IDs to their image locations for fast page loads. Why are the others incorrect? B. Querying object metadata directly across a cloud storage bucket is inefficient and slow compared to using a database, violating the requirement to show images quickly. C. Self-managing a distributed file system on persistent disks introduces unnecessary operational overhead and scaling complexity compared to using fully managed cloud storage. D. Using a self-managed distributed file system creates excessive operational complexity when native managed object storage, cloud storage, is better suited for unstructured media files.
Dress4WM has end-to-end tests covering 100% of their endpoints. They want to ensure that the move to the cloud does not introduce any new bugs. Which additional testing methods should the developers employ to prevent an outage? The options are: Option A. They should enable Google Stackdriver Debugger on the application code to show errors in the code. Option B. they should add additional unit tests and production scale load tests on their cloud staging environment. Option C, they should run the end-to-end tests in the cloud staging environment to determine if the code is working as intended. Option D, they should add canary tests so developers can measure how much of an impact the new release causes to latency.
To arrive at the correct answer, we focus on the keywords. Move to the cloud does not introduce any new bugs, additional testing methods, prevent an outage.
The correct answer is option B. They should add additional unit tests and production scale load tests on their cloud staging environment.
Why is this correct? B. Adding unit tests isolates granular code logic, while production scale load testing in a cloud staging environment verifies that the cloud infrastructure can handle actual traffic demands and stress without causing outages. Why are the others incorrect? A. Stackdriver Debugger is an inspection tool used for troubleshooting application state in production, not a pre-deployment testing method for outage prevention. C. Dress4Win already possesses 100% end-to-end test coverage. Running them alone in cloud staging validates functional behavior, but fails to test system performance under heavy load. D. Canary deployments introduce changes to live production traffic gradually. They measure deployment impact in production rather than testing performance pre-release to actively prevent outages.
You want to ensure Dress4Win sales and tax records remain available for infrequent viewing by auditors for at least 10 years. Cost optimization is your top priority. Which cloud services should you choose? The options are: Option A, Google Cloud Storage Coldline to store the data, and CIDL to access the data. Option B, Google Cloud Storage Nearline to store the data, and CIDL to access the data. Option C, Google BigTab with US or EU as location to store the data, and Cloud to access the data. Option D, BigQuery to store the data, and a web server cluster in a managed instance group to access the data. Google Cloud SQL mirrored across 2 distinct regions to store the data, and a Redis cluster in a managed instance group to access the data.
To arrive at the correct answer, we focus on the keywords. Records remain available for infrequent viewing by auditors, at least 10 years. Cost optimization is your top priority.
The correct answer is option A, Google Cloud Storage Coldline to store the data, and CIDL to access the data.
Why is this correct? A. Cloud Storage Coldline is specifically designed for data access less than once a year, offering the lowest storage cost for long-term archival over 10 years among the given options. CIDL is the standard tool to interact with cloud storage. Why are the others incorrect? B. Cloud Storage Nearline is intended for data accessed roughly once a month. Since cost optimization is the top priority for 10-year archival of infrequently viewed data, Coldline is significantly cheaper than Nearline. C. Bigtable is a high-performance NoSQL database meant for large-scale, low-latency workloads. It is extremely expensive and vastly over-provisioned for simply archiving static records for infrequent viewing. D. BigQuery, Cloud SQL, and Redis with managed instance groups are operational and analytical systems. Maintaining these active compute and database resources would incur massively higher costs compared to simple object storage like Coldline.
The current Dress4Win system architecture has high latency to some customers because it is located in one data center, AS of a future evaluation and optimizing for performance in the cloud. Dress4Win wants to distribute its system architecture to multiple locations when Google Cloud Platform. Which approach should they use? The options are: Option A, use regional managed instance groups and a global load balancer to increase performance because the regional managed instance group can grow instances in each region separately based on traffic. Option B, use a global load balancer with a set of virtual machines that forward the requests to a closer group of virtual machines managed by your operations team. Option C, use regional managed instance groups and a global load balancer to increase reliability by providing automatic failover between zones in different regions. Option D, Use a global load balancer with a set of virtual machines that forward the requests to a closer group of virtual machines as part of a separate managed instance groups.
To arrive at the correct answer, we focus on the keywords, high latency, located in one data center, optimizing for performance, distributed system architecture to multiple locations.
Correct answer is option A. Use regional managed instance groups and a global load balancer to increase performance because the regional managed instance group can grow instances in each region separately based on traffic.
Why is this correct? A. Regional managed instance groups combined with a global load balancer route user requests to the nearest region. This allows each region to scale independently based on local traffic load, directly reducing latency and optimizing overall performance. Why are the others incorrect? B. Forwarding requests through intermediate virtual machines introduces extra network hops, increases latency, and adds unnecessary operational complexity instead of leveraging native autoscaling. C. While this setup enhances reliability, the option incorrectly emphasizes cross-region failover rather than the primary goal of optimizing performance through region-specific traffic scaling. D. Adding an additional layer of proxy virtual machines to forward requests creates extra latency and architectural complexity, contradicting the performance optimization objective.
For this question, refer to the Dress4Win case study. Dress4Win is expected to grow to 10 times its size in 1 year with a corresponding growth in data and traffic that mirrors the existing patterns of usage. The CIO has set the target of migrating production infrastructure to the cloud within the next 6 months. How will you configure the solution to scale for this growth without making major application changes and still maximize the ROI? The options are: Option A, migrate the web application layer to App Engine, and MySQL to Cloud Data Store, and NAS to cloud storage. Deploy RabbitMQ, and deploy Hadoop servers using Deployment Manager. Option B, migrate RabbitMQ to Cloud Pub/Sub, Hadoop to BigQuery, and NAS to Compute Engine with persistent disk storage. Deploy Tomcat, and deploy Nginx using Deployment Manager. Option C, implement managed instance groups for Tomcat and Nginx. Migrate MySQL to Cloud SQL, RabbitMQ to Cloud Pub/Sub, Hadoop to Cloud Dataproc, and NAS to Compute Engine with persistent disk storage. Option D, implement managed instance groups for the Tomcat and Nginx. Migrate MySQL to Cloud SQL, RabbitMQ to Cloud Pub/Sub, Hadoop to Cloud Dataproc, and NAS to cloud storage.
To arrive at the correct answer, we focus on the keywords, 10 times its size in 1 year, migrating production infrastructure to the cloud, without making major application changes, maximize the ROI.
The correct answer is option D, implement managed instance groups for the Tomcat and Nginx. Migrate MySQL to Cloud SQL, RabbitMQ to Cloud Pub/Sub, Hadoop to Cloud Dataproc, and NAS to cloud storage.
Why is this correct? D. Managed instance groups allow scaling Tomcat and Nginx seamlessly. Cloud SQL, Cloud Pub/Sub, Cloud Dataproc, and cloud storage replace existing architecture with fully managed services requiring minimal application changes, optimizing operational costs and ROI. Why are the others incorrect? A. Migrating MySQL to Cloud Data Store and web layers to App Engine requires major application code rewrites and database model redesign, violating the core constraint. B. Migrating Hadoop jobs directly to BigQuery requires redesigning data pipelines, and using Compute Engine with persistent disk to replace NAS adds unnecessary compute management overhead. C. Replacing NAS with Compute Engine persistent disk requires managing custom file server instances, which increases operational burden and costs compared to using cloud storage.
For this question, refer to the Dress4Win case study. Considering the given business requirements, how would you automate the deployment of web and transactional data layers? The options are: Option A, deploy Nginx and Tomcat using Cloud Deployment Manager to Compute Engine. Deploy a Cloud SQL Server to replace MySQL. Deploy Jenkins using Cloud Deployment Manager. Option B, Deploy Nginx and Tomcat using Cloud Launcher. Deploy a MySQL server using Cloud Launcher. Deploy Jenkins to Compute Engine using Cloud Deployment Manager scripts. Option C. Migrate Nginx and Tomcat to App Engine. Deploy a Cloud Data Store server to replace the MySQL server in a high availability configuration. Deploy Jenkins to Compute Engine using Cloud Launcher. Option D. Migrate Nginx and Tomcat to App Engine. Deploy a MySQL server using Cloud Launcher. Deploy Jenkins to Compute Engine using Cloud Launcher.
To arrive at the correct answer, we focus on the keywords, given business requirements, automate the deployment of web and transactional data layers.
The correct answer is option A, deploy Nginx and Tomcat using Cloud Deployment Manager to Compute Engine. Deploy a Cloud SQL server to replace MySQL. Deploy Jenkins using Cloud Deployment Manager.
Why is this correct? A. Cloud Deployment Manager provides infrastructure as code automation for deploying Nginx, Tomcat, and Jenkins on Compute Engine. Replacing self-managed MySQL with managed Cloud SQL fulfills transactional data layer requirements with minimal migration refactoring. Why are the others incorrect? B. Cloud Launcher, now GCP Marketplace, launches pre-packaged individual software instances, making it unsuitable for writing custom automated deployment templates across the entire stack. C. Migrating MySQL to Cloud Data Store changes the database paradigm from relational to NoSQL, requiring extensive application re-architecture rather than a straightforward automated migration. D. Moving to App Engine requires refactoring the existing application stack, and Cloud Launcher lacks the template-driven infrastructure automation provided by Cloud Deployment Manager.
For this question, refer to the Dress4Win case study. Which of the compute services should be migrated as is and would still be an optimized architecture for performance in the cloud? The options are: Option A, web applications deployed using App Engine standard environment. Option B, RabbitMQ deployed using an unmanaged instance group. Option C, Hadoop/Spark deployed using Cloud Dataproc Regional in high availability mode. Option D, Jenkins, monitoring, Bastion hosts, security scanner services deployed on custom machine types.
To arrive at the correct answer, we focus on the keywords, compute services, migrated as is, optimized architecture for performance in the cloud.
The correct answer is option C, Hadoop/Spark deployed using Cloud Dataproc Regional in high availability mode.
Why is this correct? C. Cloud Dataproc provides a fully managed environment for running Hadoop and Spark jobs, allowing Dress4Win to migrate their existing big data workloads as is without rewrite while gaining cloud-native scalability and high availability. Why are the others incorrect? A. Migrating web applications to App Engine standard environment requires code modifications and structural changes, so it cannot be performed as is. B. Deploying RabbitMQ on unmanaged instance groups increases maintenance overhead and is suboptimal for cloud operations compared to managed messaging services. D. While these management tools can be migrated to Compute Engine, using unmanaged custom instances for infrastructure tools is a plain lift and shift rather than an optimized cloud architecture.
For this question, refer to the Dress4Win case study. To be legally compliant during an audit, Dress4Win must be able to give insights in all administrative actions that modify the configuration or metadata of resources on Google Cloud. What should you do? The options are: Option A, use Stackdriver Trace to create a trace list analysis. Option B, use Stackdriver Monitoring to create a dashboard on the project's activity. Option C, enable Cloud Identity Aware Proxy in all projects, and add the group of administrators as a member. Option D, use the activity page in the GCP console and Stackdriver logging to provide the required insight.
To arrive at the correct answer, we focus on the keywords, legally compliant during an audit, insights in all administrative actions that modify the configuration or metadata of resources.
The correct answer is option D, Use the activity page in the GCP console and Stackdriver logging to provide the required insight.
Why is this correct? D. Admin activity audit logs, which are accessible via the GCP console activity page in Cloud Logging, formerly Stackdriver logging, automatically log all actions that modify resource configurations or metadata for compliance and auditing purposes. Why are the others incorrect? A. Stackdriver trace is used for distributed tracing and performance latency analysis of applications, not for tracking administrative resource modifications. B. Stackdriver monitoring focuses on performance metrics, uptime, and alerting, rather than recording audit logs of configuration changes. C. Cloud Identity Aware Proxy, IAP, controls access to applications and VMs using identity verification, but does not provide administrative audit log tracking.
For this question, refer to the Dress4Win case study. You are responsible for the security of data stored in cloud storage for your company, Dress4Win. You have already created a set of Google groups and assigned the appropriate users to those groups. You should use Google best practices and implement the simplest design to meet the requirements. Considering Dress4Win's business and technical requirements, what should you do? The options are: Option A, assign custom IAM roles to the Google groups you created in order to enforce security requirements. Encrypt data with a customer-supplied encryption key when storing files in cloud storage. Option B, assign custom IAM roles to the Google groups you created in order to enforce security requirements. Enable default storage encryption before storing files in cloud storage. Option C, assign predefined IAM roles to the Google groups you created in order to enforce security requirements. Utilize Google's default encryption at rest when storing files in cloud storage. Option D, assign predefined IAM roles to the Google groups you created in order to enforce security requirements. Ensure that the default Cloud KMS key is set before storing files in cloud storage.
To arrive at the correct answer, we focus on the keywords: security of data stored in cloud storage, Google best practices, simplest design.
The correct answer is option C, assign predefined IAM roles to the Google groups you created in order to enforce security requirements. Utilize Google's default encryption at rest when storing files in cloud storage.
Why is this correct? C. Google best practices recommend using predefined IAM roles to reduce management overhead. Utilizing Google's default encryption at rest requires no extra configuration, perfectly fulfilling the requirement to implement the simplest design for securing data in cloud storage. Why are the others incorrect? A. Custom IAM roles and customer-supplied encryption keys, CSEK, both introduce significant management overhead and complexity. This violates the requirement to implement the simplest design, as there are no specific compliance needs dictating CSEK over default encryption. B. Custom IAM roles require manual maintenance, violating the simplest design principle. Furthermore, Google Cloud Storage encrypts data at rest by default automatically, so there is no need to manually enable default storage encryption. D. While predefined IAM roles are optimal, managing a Cloud KMS key, CMEK, adds unnecessary complexity to the architecture. Relying on Google's default encryption at rest is simpler and fully meets standard security requirements.
For this question, refer to the Dress4Win case study. You want to ensure that your on-premises architecture meets business requirements before you migrate your solution. What change in the on-premises architecture should you make? The options are: Option A, replace RabbitMQ with Google Pub/Sub. Option B, downgrade MySQL to version 5.7, which is supported by Cloud SQL for MySQL. Option C, resize compute resources to match predefined compute engine machine types. Option D, containerize the microservices and host them in Google Kubernetes Engine.
To arrive at the correct answer, we focus on the keywords: on-premises architecture meets business requirements, change in the on-premises architecture.
The correct answer is option D, containerize the microservices and host them in Google Kubernetes Engine.
Why is this correct? D. Containerizing microservices provides portability and consistent deployment environments, enabling seamless scaling and migration to Google Kubernetes Engine (GKE) to meet business requirements. Why are the others incorrect? A. Google Pub/Sub is a managed cloud service and cannot be deployed in an on-premises environment. B. Downgrading MySQL is unnecessary and creates operational risks, as Cloud SQL supports modern versions of MySQL. C. Compute Engine supports custom machine types, so pre-aligning on-premises compute sizes to match predefined specs is unnecessary.